Timeless concepts from Physics Helpline. In this video tutorial, we will discuss 3 questions. These questions are taken from the JEE main exam of 2021. The questions are as follows. Question 1. This is a multiple choice question. It is about the velocity displacement graph describing the motion of a bicycle. This graph is shown in the figure. We are required to find the corresponding acceleration displacement graph for the same motion. The options are given in the question. We are required to find the correct option. Before proceeding to solve the problem, let us understand the related concepts. We are required to find the acceleration displacement graph from the given velocity displacement graph of the motion of the bicycle. Therefore, we need to establish a relation between acceleration and velocity. Now, acceleration is defined as A is equal to dv by dt. We will multiply and divide by dx. Therefore, we get A is equal to dv by dx into dx by dt. But dx by dt is equal to v, which gives A is equal to v into dv by dx, which gives acceleration is equal to velocity into slope of the vx graph. Now, for the answer, we will consider the motion of the bicycle for the first interval from x is equal to 0 to 200 meters in this, when the velocity behaves in this manner. For this interval, what is the value of dv by dx? What is dv? v changes from 10 meters per second to 50 meters per second. Therefore, dv is equal to 50 minus 10 is equal to 40. And x changes from 0 to 200 meters. Therefore, dx will be equal to 200 minus 0, which is equal to 200. Therefore, dv by dx is equal to 40 by 200, which is equal to 1 by 5, which is a constant, which gives us that acceleration is directly proportional to velocity. So we will find the corresponding acceleration corresponding to the velocities of 10 meters per second and 50 meters per second. So when v is equal to 10, we will use the same equation A is equal to v into dv by dx. So A will be equal to v is 10 into dv by dx is equal to 1 by 5, which gives us acceleration A is equal to 10 into 1 by 5, which is equal to 2 meters per second square, which is marked in the figure here. When v is equal to 50 meters per second, acceleration A will be equal to 50 into 1 by 5, which will be equal to 10 meters per second square, which is marked in the figure here. Therefore, the shape of the acceleration displacement graph between the interval 0 to x is equal to 0 to 200 meters will be like this. Now, for the second interval, x is equal to 200 meters to 400 meters. In this interval, we observe that velocity remains constant at 50 meters per second, which tells us that dv by dx will be equal to 0. Therefore, acceleration A is equal to v into dv by dx, which will be equal to 0. Therefore, we have plotted the acceleration in the graph on the x-axis for the interval x is equal to 200 meters to 400 meters. We have already found the AX graph between the interval 0 to 200, and now for 200 to 400, combining the two, we get the correct acceleration displacement graph for the motion of the bicycle. Therefore, the correct option is A. Now, for question 2, this is also a multiple choice question. This is about the time period of a simple pendulum which is oscillating inside a lift. It is given in the question that when the lift is stationary, the time period of the pendulum is equal to t. We are required to find the time period of the pendulum when the lift is moving up with acceleration a is equal to g by 2. The options are given in the question. We are required to find the correct option. Before proceeding to solve the problem, let us understand the related concepts. The effective acceleration due to gravity inside a lift. Now, when the lift is stationary, in the first figure, the lift is stationary and therefore the tension in the string will be T1, which will be equal to weight of the bob mg, where m is the mass of the bob. Therefore, we write T1 is equal to mg. In the second figure, when the lift is moving up with acceleration a, then the tension in the string will be T2, which is equal to mg plus ma. Therefore, we write T2 is equal to mg dash, where g dash is the effective acceleration due to gravity. Therefore, T2 will be equal to mg plus ma, which gives us g dash is equal to g plus a. In the third figure, the lift is moving down with acceleration a. Therefore, the tension in the string in this case will be T3, which will be equal to mg minus ma. Therefore, we write T3 is equal to mg dash, where g dash is the effective acceleration due to gravity in this case. Therefore, T3 will be equal to mg minus ma, which gives us g dash is equal to g minus a. Now, for the answer, it is given in the question that when the lift is stationary, the time period of the pendulum is t. Therefore, we write t is equal to 2 pi root over L by g, where L is the length of the pendulum and g is the acceleration due to gravity. Now, when the lift is moving up with acceleration a is equal to g by 2, then the time period t dash will be equal to 2 pi root over L by g dash, where g dash is the effective acceleration due to gravity. Now, we have already found that g dash is equal to g plus a when the lift is moving up with acceleration a. Now, in this case, it is given that a is equal to g by 2. Therefore, g dash is equal to g plus g by 2, which is equal to 3g by 2. Putting the value of g dash in this equation for t dash, we get t dash equal to 2 pi root over 2l by 3g, which is equal to root over 2 by 3 into 2 pi root over L by g. And this bracketed quantity is nothing but it is equal to t. Therefore, we get t dash is equal to root over 2 by 3 into t, which is the answer to the question. Therefore, the correct option is C. Now, for question 3, this is an integer type question. A ball of mass 10 kg moving with velocity 10 root 3 meter per second along x-axis. This collides with another ball of mass 20 kg which is at rest. After the collision, the first ball comes to rest and the second one disintegrates into two equal pieces. One of the pieces starts moving along the y-axis at a speed of 10 meters per second and the second piece starts moving at a speed of 20 meters per second at an angle theta with x-axis as shown here. The configuration of the pieces after the collision is shown in the figure. We are required to find the value of theta to the nearest integer. Now, for the answer, we will apply the principle of conservation of momentum, linear momentum, before and after collision. Now, before collision, the configuration is like this. Ball B is at rest, its mass is 20 kg, and ball A of mass 10 kg, and it is moving along the x-axis with speed 10 root 3 meter per second. Therefore, we write MA is equal to 10 kg and VAX is equal to 10 root 3 meter per second. X is written because it is moving in the x direction. Therefore, linear momentum of A along x-axis will be equal to 10 kg into 10 root 3 meter per second, which will give us equal to 100 root 3 kg meter per second. And we observe that A is moving along x-axis, it has got no motion in the y direction, therefore PAY is 0. And B is also completely stationary, no motion, therefore linear momentum of B in x direction as well as y direction will be equal to 0. This is before collision. Now after collision, we observe that A comes to rest. Therefore, linear momentum of A along x and also along y will be equal to 0. And B disintegrates into two equal pieces. So, mass of B is equal to 20 kg. Therefore, mass of B1 will be 10 kg and mass of B2 is also equal to 10 kg. Now, B1 moves in the y direction with velocity 10 meters per second. Therefore, we write linear momentum of B1 in the y direction will be equal to mass into velocity. Therefore, mass is 10 kg and velocity is 10 meters per second, which gives us 100 kg meter per second along y direction. And B2 moves with speed 20 meters per second in a direction making angle theta with x-axis. Therefore, this velocity will have one x component and one y component. So, x component will be equal to 20 cos theta towards right, and the y component will be equal to 20 sin theta in the downward direction. Therefore, the linear momentum of B2 in the x direction will be equal to its mass, that is 10 kg, multiplied by its velocity in the x direction is 20 cos theta, which is equal to 200 cos theta kg meter per second. And linear momentum of V2 in the y direction, it is in the downward direction, it moves with velocity 20 sin theta meter per second in the downward direction. Therefore, we multiply 10 kg mass multiplied by minus 20 sin theta. This will give us PB2y is equal to minus 200 sin theta. Now, we can solve the problem by equating x component of linear momentum before and after collision. The same can also be achieved by equating the y component of linear momentum. First, we will equate the x component of linear momentum before and after collision. Now, before collision, there was only one term, that is PAX is equal to 100 root 3 kg meter per second. Therefore, we put 100 root 3 on the LHS. On the RHS is after collision. After collision in the x direction, linear momentum in the x direction, we have got only one term here, 200 cos theta. 200 cos theta. Because you see PB1y is also in the y direction and this one is also in the y direction. So, x direction only one linear momentum term. Therefore, we get 100 root 3 is equal to 200 cos theta, which gives cos theta is equal to 100 root 3 divided by 200, which is equal to root 3 by 2, which implies theta is equal to 30 degrees. Therefore, the nearest integer is 30, which is the answer to the question. Now, we will equate the y component of linear momentum before and after collision to get the same result. Now, before collision, the configuration was like this. Because we want to equate the y component of linear momentum, we observed that before collision there was no motion in y direction. Therefore, the linear momentum in the direction of y axis will be equal to 0. That is what we have put on the LHS. On the RHS will be the linear momentum in y direction after collision. So, this figure shows the linear momentum in the after collision in the y direction. Now, B1, mass of B1 is 10 kg and it is moving along the y-axis with speed 10 meters per second. Therefore, linear momentum of B1 in the y direction will be equal to 10 into 10, which is equal to 100 kg meter per second. That is what we have put here. First term on the RHS. And second one, PB2. B2 moves with velocity 20 sin theta meter per second in the downward direction. Therefore, the linear momentum of B2 in the y direction will be equal to mass 10 kg multiplied by velocity minus 20 sin theta because it is moving in the downward direction, which gives us PB2y is equal to minus 200 sin theta kg meter per second. That is what we have put here, minus 200 sin theta. This gives 200 sin theta will be equal to 100 or sin theta will be equal to 100 divided by 200, which will be equal to 1 by 2, which implies theta is equal to 30 degrees. Therefore, the nearest integer is 30, which is the answer to the question. This completes the answer to all the questions in the video tutorial. Thanks for watching. If the video is helpful, then please like, share and subscribe.